like to show you how to use your graphing calculator more effectively. I just think of this as the graphical intersect method to solve an equation. This can be done with any equation at all, which is the beautiful part, and the thought process is very much the same. So let's just say that we're working with an investment problem, and we want to ask a question that involves not just evaluating the compound interest formula, but solving for something within the compound interest formula. So we know from our experiences that A equals P times 1 plus R over N to the NT power is what is used to calculate the future value of investments, A, based on how much you deposit, P, at an interest rate of R, that's as a converted to a decimal. Compounding takes place N times per year for T years. So in this case, our question is, if you invest $3,400 at an interest rate of 8% compounded monthly, how long will it take you for you to double your money? So what I know here is I know that I'm going to invest P equals 3,400. I want to have double that amount. Well, 2 times 3,400 is going to be 6,800. I also know that my interest rate is R equals 8%. 8% means 8 per 100, or 8 divided by 100, which is 0.08. N is the number of times interest is going to be compounded throughout the course of 1 year, which is 12. And T is the number of years, which is exactly what is unknown here. So what I have is the equation is 6,800 equals 3,400 times 1 plus 0.08 divided by 12 to the 12t power. So t is my unknown. Now what I want to do is I basically want to figure out when this function, well, think about this right hand side. This is a function that is exponential, and it's going to increase from my base of 3,400. And at some point in time, this horizontal line represents when it crosses $6,800. So what I want to graph is 6,800 in one of my y equals windows and this expression in the other. So I have that done here. I have the 3,400 times parenthesis 1 plus 0.08 divided by 12, close parenthesis, raised to the power, all in parentheses, 12x. And then y2 is equal to 6,800. So to effectively be able to graph this function, I need to set my window, and that's usually the tricky part. Well, what does x represent in this problem? X is our time. So if you're earning 8% per year, we sort of have to think about kind of an intuitive domain. Well, first of all, I'm going to start my time at 0 just because I want to see from time equals 0 onwards when I start investing and how maybe rapidly that grows. And I don't know, to make 6,800, maybe if you don't know the first time around, we'll just say, oh, okay, well, it can't take more than 30 years, let's say. And we can always adjust this domain later on. Now, I don't have to worry about ymin or ymax because I'm going to take advantage of my calculator's zoom fit feature. Now, remember, zoom fit requires you to set your domain first. You don't need to worry about anything else. And then when you do zoom fit, option 0, the window, the domain is set from 0 to 30 the way we set it, but then our graphing calculator sets up our Y window. Okay, well, there's the line representing 6,800, so that means it takes far less than the 30 years to make my fortune. So I want to calculate that intersection point. Of course, I could cursor around and get approximate, but the way I'm going to do it is by using the calculate option here in my calculator. And to access calculate, I'm going to press second and the trace button. And I want to select option 5 here, which is the intersect feature. And because there is only one intersection point and 2 equations, I can press enter, enter, enter. And hopefully it jumps to the intersection. Tells me t, or in this case x, is 8.69. So t is going to take, it's going to take 8.69 years to accomplish this goal. Now, it's as simple as that to solve that equation. We didn't have to do any logarithms or anything complicated, stuff that you'll learn in college algebra if you go on. Consider question 1, but determine how long it would take if compounding took place continuously. Well, continuous compounding assumes that basically n is infinity. And mathematically, that works out or simplifies, reduces down to this equation here, where e is a constant that's approximately equal to 2.71828. Okay, so that's a constant just like pi. And again, same figures apply here. A is 6,800, P is 3,400, e raised to the r, which is 0.08. Now, n doesn't come into play here because we're compounding infinitely many times a year. Basically, your money is growing continuously throughout the year, but 8% over the course of the year. And we would again proceed in a very similar fashion. Come into our y equals screen. We're going to wipe out the first equation because that's no longer valid. That's for monthly compounding. And now we're going to plot 3,400, second, and then the ln button to access e to the power of 0.08x. Again, e is not a variable. It's just a constant that appears very frequently in mathematics. And we'll do the same thing for our window. Make sure that we like the domain. We're going to go from 0 to 30 years. We know it's not going to take that long. Especially the more you compound, the faster this all takes. So maybe I'm just going to get a nicer, you don't have to, you could leave it from 0 to 30 and then adjust accordingly. But I'll just go 0 to 15 years because I know it's going to take less than 15 years. So I'll do my zoom fit again. You have to do zoom fit again so that it updates the window based on your new domain of 0 to 15 years. And now I plot, well, there's 6,800. At that time right there is where the balance reaches $6,800. So second trace, select the intersect feature again, enter, 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 and it takes 8.66 years, which you notice is slightly less than it took before. So we're paying interest way more often. In fact, most people think if you compound interest infinitely many times a year, that it should take, it should be instant that you make that money, but it doesn't take that much less time. It takes a little bit less time to achieve the $6,800 goal. So it doesn't really matter what the equation is. The setup is very much the same. Let's say we want to ask the question, I have $500 to invest. I want to double it in 5 years. That's my goal. Well, something's got to give, right? You can't just double your money however soon you want. You've got to allow something to vary. Well, the question is, what APR would I need in order to accomplish my goal, assuming we're compounding weekly? All right, well, what do we know here? We know that we want our future balance to be 1,000. We have our initial balance, which is 500. Our interest rate is R equals, well, I don't know. That's what we're trying to figure out, question mark. N is going to be 52 since we're compounding 52 times a year. And T is going to be fixed to 5. So if I set all this up, I get 1,000 equals 500. Now this is not continuous compounding. This is compounding 52 times a year. So we go back to our compound interest formula. So I don't know what R is, so I'm going to leave that as an unknown. Divided by 52 raised to the 52 times 5 power. Okay, well again, I'm going to set up, I have an equal sign here, so I'm going to figure out when does this expression right here reach a balance of 1,000. So I'm going to come into my calculator, clear out both of my equations. Doesn't matter which one you do first here. I'll do 500 times 1 plus, well, I can't do R, I have to do X, divided by 52, raised to the parenthesis 52 times 5 power. And next I'm going to plot the 1,000 so I can see my horizontal line. In other words, when does the balance reach 1,000, just like up here, when did the balance reach 6,800? Got to set my window again. Okay, now we have to be careful here because now we have to think about what does X measure? Well, X measures the interest rate. So what is an interest rate going to be between? Well, interest rates in practice shouldn't be less than 0%, but they shouldn't be higher than 100%. I mean, in theory, I guess you could have an interest rate that pays more than 100%, but you're not going to find that kind of bank account. So in terms of what R could be between, well, as a decimal, 0% is 0. R can be between 0 and 100% is decimal equivalent to 1. So my domain is going to be 0 to 1 because, again, that's what X represents the interest rate expressed in a decimal form probably isn't going to be more than 100%. Okay, well now I'm going to do my zoom fit again, which is zoom 0. And hopefully that interest rate that I require to have is going to be somewhere between 0 and 1, I hope. All right, well, good. So there's our interest rate along this axis. This is our balance. And so our balance is a function of the interest rate is now going to allow me to calculate that intersection. So again, I'm just trying to solve, really all I'm doing is trying to solve this equation for the value of r. So I'm going to do my second trace, and it's okay that you're seeing this really, you see the horizontal line here that's plotted at 1,000. It's just as r gets really close to 100%, you're doubling your money really, really fast. Another thing that we could do here is if I don't like this window and I kind of want to see more of this region where that intersection occurs, I can come back and change my window. Maybe not 0 to 100%, but maybe I'll just go 0 to, looks like it's going to be less than 25% that I require. Again, I'll do zoom fit, and that will set up my Ymin, Ymax for me, and that's starting to look a lot better. Let's see where that intersection takes place. There we go. Looks now much nicer. And so I can do my second calc, intersect, number 5, enter, enter, enter. And this tells me that I require r, the value of r that solves this equation is 0.1388. So r is about 0.1388. Well, what does that mean? Well, that's the decimal equivalent to the percentage, the APR that I require. So this means I would require 13.88% APR in order to accomplish my goal. Well, that can still maybe be feasible. You probably can't put it into a bank account, and you can't go to Chase and they won't pay you, almost 14%. But maybe you could think about some stocks that you could purchase or mutual funds or some sort of investment scenario that has been yielding at least that much in previous years. So at least you know what you need in order to accomplish that goal. As to whether it's feasible is then a question that we can answer later on. So again, this applies to any equation. I could be trying to solve anything I want. Let's say I want to know the answer to 600 equals, I don't know. Let's say we want to solve for n. Maybe we want to figure out how many times I would need to compound per year at 10%. So that I reach $600 in 5 years. Okay, well, same thing here. I could set this up, except I'll have two x's, one in the exponent and one in the denominator. And again, I could do the intersection feature and figure out what value of n, how many times I need to compound a year in order to accomplish this goal. So just a few examples. Hopefully this has been helpful, and we'll go ahead and stop there.